So this is the feedback back for our Year 12 Assessment 3, Part B, the part that the students completed in class. Question 1 asked the students to label 3 energy systems in their book. A was the aerobic, B was lactic acid, and C was the alact acid or the ATP-PC system, which was pretty straightforward, 1 mark each. Question 2 asked students to describe the role that oxygen plays in each energy system. And the key part here was, even though that lactic acid and ATP-C system have no role of oxygen, they still need to be mentioned to demonstrate your level of understanding. So we just talk about the role that aerobic system has in the use of oxygen. I've got a sample answer down here that goes through what I like about it is underlying the ATP system and the lactic acid system both do not require the use of oxygen. Straight away it's been mentioned. Within the aerobic energy system, oxygen is vital in the resynthesis process of producing ATP. Then it goes further on to give an example of how this could be applied, such as in running a long distance. So it's a great answer. Very, very well done. So it's a good one to read, and I'd recommend students having a read of that for sure. Next one, I'll try and just move this one up a bit if we can, just to make it a bit simpler. All it is looking at in the lactic acid system, what happens to the athlete if they continue to exercise at 80% of maximal effort. And just some things up here that I've written in there, lactic acid will build up in the muscles, leading to fatigue and exhaustion. Well, eventually the athlete will have to slow down or even stop. So as the answer sample goes on here, it says that if the athlete continues to exercise at 80% of their maximum effort in the lactic acid system, they will only be able to exercise at that rate, I think, for slightly over a minute, as the lactic acid system's duration only lasts between 1 to 3 minutes depending on their intensity of the exercise. Since 80% is quite high intensity, they will not be able to perform at the same rate for more intense. So again, they've got some things in here about the lactic acid system, underlined the key elements of it, talked about the duration. They've said how long it works for, what happens in the lactic acid system, which leads to fatigue. All right, further talks about being fatigued here, so the athlete having to stop and slow down. Includes an example, which helps support what their answer has been saying about the use of lactic acid system, and if they continue at that intensity, there'll be accumulation in the body and their muscles will tire, they'll need to slow down. So there's some of the key things that at 80%, if you continue to do that, fatigue's going to kick in, build up of lactic acid in the muscles, the athlete's going to have to slow down or even stop to allow recovery. That's what that question was asking. Question 4. Why does ATP-PC system drop so dramatically? Some things I'll just put in here. Phosphocreatine exhausted in the body after 10 to 12 seconds at 95 to 100% of maximal effort. So that's a little easy thing there that most boys would know. If we look at just the sample answer here, we'll see that the ATP energy system's main source of fuel is creatine phosphate. The body only has a limited supply of creatine phosphate. The reason why it drops so dramatically is that the body has only a small amount of creatine phosphate. It takes a short explosive burst of energy, lasting approximately 10 to 12 seconds to exhaust this creatine phosphate. So he's exactly reinforced what I mentioned up the top about it lasts for 10 to 12 seconds, then it was exhausted, which is why there's such a quick drop. After this high intensity, short burst of energy, the ATP system then has to refuel, and he's unable to keep performing at the same high intensity rate as it did for 10 to 12 seconds. So after 10 to 12 seconds, it drops dramatically until the creatine phosphate is resynthesized back together again, which usually takes approximately 2 minutes. Very good. Well done. Good answer there, supporting all the things that need to be included. And the last one says, last question was, after 90 seconds, which energy system becomes the predominant energy system and why? And I've just put a few things in here for some quick points. The predominant energy system is the aerobic system. The other two systems had both exhausted all their energy stores and were on the way down. This is because ATP stores in the ATP system and the lactic acid system have been exhausted and it only be resupplied at rest. If the athlete wishes to continue exercising, the aerobic system will continue to supply the working muscles with ATP. So if you notice on yours, I've circled it for the system that they've said the predominant. So the predominant energy system after 90 seconds of exercise will be the aerobic system. This student's made the correction, which is great. The ATP system only lasts 10 to 12 seconds, so it can't be that one. No longer work. The lactic acid system, so after the ATP is exhausted, the body turns to the lactic acid system to provide carbs. However, it lasts for approximately 1 minute at moderate intensity. Therefore, the athlete has been running for 70 to 70 odd seconds. As fuel is now starting to exhaust as a result of the by uric acid being created without oxygen. Lactic acid is produced. This has caused the athlete to fatigue and slow down. And again, some underlining here to point out some of the key aspects. So as a result of this, because the anaerobic threshold, the body is in the aerobic system. As oxygen is being passed to the working muscles after fuel from ATP and lactic acid system is exhausted, now oxygen is present in the muscles, which eliminate the lactic acid and hydrogen ions, removing waste products and allowing the athlete to continue exercise at a virtually endless duration after 90 seconds of exercise. Another very good answer. So that was the part B, which is the part you did in class.